You know, when ground-based electronic nav aids came along, they changed the whole world of aviation because they made possible the navigation accuracy needed for safe IFR flight. Now you can identify a nav aid and you can track from nav aid to nav aid and stay on surveyed routes. And you can get clever too. You can use cross bearings or radials and you can make a new fix away from the nav aids themselves. Here's a case where you use two radials to make a fix. Now these cross bearings or radial intersections do have some limitations because first of all you have to be in range of two nav aids, and secondly the angle you make with the cross bearings has to be big enough to minimize bearing error. With a plus or minus 4-degree bearing error, you could be anywhere in this area and still have centered needles. But if the angle is bigger, the area that you'll be in is much smaller. So the geometry of the fix makes a big difference when you're using radials. Then DME came along and it solved that problem and created a whole new range of possibilities, because when you add a DME co-located with a VOR, you suddenly have an infinite number of fixes as long as you're within the service range of the VOR and DME. In other words, you can make up any combination of VOR DME that you can think of and it becomes a fix. Then somebody realized that if you keep a constant distance from a station, you can fly a defined course. It won't be a straight course, but it will be a defined course, and that means the DME arc was born. It's a way to fly a specified track without having to overfly the nav aid. Now, this innovation gave the terminal area and approach planners a lot more flexibility. Today, the FAA often includes DME arcs to help you get to the airport. Now, if you want to fly a DME arc and you're flying a DME-equipped airplane, life is pretty simple. You just tune your nav radio to the VORTAC or DME station. Then you read the distance from the station on the DME indicator. Now, some airplanes, like the new Skyhawk, have GPS receivers instead of DME, but the technique is the same. You select the VORTAC or DME station and use it as the active waypoint in your GPS. Then you use the GPS as if it were a DME. So let's look at how you can fly a DME arc using the distance and bearing information on your GPS. Let's take a look at an example of how you'd fly a DME arc. We'll use the 10 DME arc, and let's assume that you want to fly around the OKT VORTAC. Now let's also say that you're outbound on the 325 radial. Now you'll want to plan your turn to intercept the DME arc in such a way that the station ends off your right wing and you're established right on that 10 DME arc, so you'll do a 90-degree turn to the right. Now you'll want to plan to lead that turn so you don't overshoot the 10 DME while you're still turning. By the way, about a half nautical mile lead usually works out for airplanes of 150 knots or less. Now, in this case, what you do is you start your turn to 055 while you're 9.5 nautical miles from the station. If, on the other hand, you were approaching inbound OKT from outside the 10 DME arc, you'd start your turn at 10.5 nautical miles. I knew you could figure that out. Now, when you're flying a DME arc, you're maneuvering constantly to keep a 10-mile, in this case, distance, a constant distance from the station, and you're flying headings that keeps the station nearly off the right wing. And the easiest way to see that your heading keeps the station off your right wing is to use these 90-degree indices on either side of your heading indicator. So when you're flying a DME arc, your heading at any given point would be at about a 90-degree angle to the bearing to the station. Now you have a real advantage when you're using a GPS to fly a DME arc because you can read the bearing to the station right off the screen and you don't have to rotate the OBS like you do in a VOR to find your bearing. Now in theory, when you're flying a DME arc, you'd just be in a constant turn at just exactly the bank angle that would give you the proper radius of turn. Well, on a typical DME arc, say at 10 miles, that would be a pretty doggone small bank angle, and I can tell you right now, I wouldn't be able to maintain that little tiny bank angle precisely. So what you really do is fly a bunch of short legs and change the heading as the bearing to the station changes. Now in a no-wind situation, each short leg will start with the bearing to the station just 5 degrees in front of the wing. Here it's 145 degrees, so you put 145 degrees, just 5 degrees in front of the wing. Then when it moves to 5 degrees behind the wing, you'd make a 10-degree heading change and once again put the bearing 5 degrees in front of the wing. Now, because there is almost, and I can tell you in my airplane, there is always a wind, you're going to need to know how to correct for a crosswind. Now, if there's a crosswind in any given point on this arc, you'll need to crab into the wind for that segment. So here we have a wind, you're crabbed into the wind, and that means if the wind is from the station side, you need to put the bearing to the station a little further in front of the wing. In this case, we have a 145-degree bearing to the station. We put it 10 degrees in front of the wing in this particular case. And so if the wind is on the other side, of course, you'd crab the other direction, then you put the bearing to the station behind the wing. I knew you could figure that out. Now, your course guidance while you're doing all of this is not the needle, it's the distance to the station. Now let's put some numbers into this and make a real-world example out of it. Let's say you want to track a 10-mile arc to the left around the station, and you use your GPS to find out that your current bearing to the station is 270 degrees. Well, with a bearing to the station of 270 degrees, a 360-degree heading would put that station directly off your left wing. But if your distance from the station is actually 10.5 miles, then you'd need to turn to the left to get back to that 10-mile arc. In order to do that, you'd turn left and put the bearing to the station, say, 10 degrees in front of the left wing. And then when you get back to the correct distance of 10 miles, you'd have to turn some back to the right. Now, you wouldn't want to turn all the way back to 360 degrees because you've advanced around the arc some, and your bearing to the station is no longer 270 degrees. Now, on the other hand, suppose your distance to the station is only 9.5 nautical miles. Well, that means you're inside that 10 DME arc, and you'll need to turn so that the bearing to the station now would be behind the left wing. You do that by turning a little bit to the right, and the bearing to the station now is behind the left wing, say 10 degrees. Now, let's assume that you have completed the arc nicely and you're approaching the radial at the end of the arc. Well, once again, you want to lead your turn so you don't overshoot it. On a 10-mile arc, you could use about a 5-degree lead, and it should work out pretty well at airspeeds of 150 knots or less. Well, now you have another tool in your IFR flight bag, and this one is extra special because it gives you the means to navigate on a specified course even though you're not flying directly to or from a nav aid.